Today we're going to talk about synthetic division. Now, synthetic division, what it does is it allows us to have a shortcut for long division of polynomials. However, it only works when you have linear factors. For example, linear factors, these are factors such as x plus 2, possibly 3x minus 1, any kind of factor where the x is to the first power. So on both of these, my x is to the first power, which makes this a linear factor. Now, the process with synthetic division is going to be slightly different than what we've done in the past. So let's start with an example, and it's easiest to go through the steps when we can see an example to help us out. So let's start with 3x cubed plus 7x squared plus 13x plus 9, and I want to divide that polynomial by x plus 1. Now, in synthetic division, because it's a shortcut, we're not going to write down everything we see in this polynomial. With synthetic division, what we're doing is we only want to consider the coefficients on each of the terms. Now, you must make sure that the polynomial is in descending order, and as you can see, this is descending order. I also need to make sure that every power is represented, and x cubed, x squared, x to the first power, and then none. Otherwise, our synthetic division won't work. So what we're going to do is we're going to start by writing the coefficients only. The x cubed has a coefficient of 3, 7, 13, and 9. And so what we're going to do is we're going to make this, looks like almost like a reverse division sort of box. Now what we need to do is we need to be able to divide by something. So this is kind of like thinking of how I put my terms underneath a division bar. I need to have some sort of divisor. Now the divisor is going to be based off of this x plus 1. I want to divide by this polynomial. However, there is more meaning to this x plus 1 than what we've already discussed. In the next section, we're going to be talking about how to find zeros or roots of a polynomial. And so what that means is when I do synthetic division, I want to know if this binomial here is a factor, but I also want to know if it is one of our zeros. And so to figure out what number goes here as my divisor, because I'm just looking at numbers, I'm not looking at variables, I need to take x plus 1 and I need to set this equal to 0. Because I need to be able to think about, is this a zero? Is this a factor? As we start learning in the next section, zeros and factors have the same meaning. So I'm going to set this polynomial right here equal to 0, and I'm going to solve. And so when I get the value for x that creates the 0, that value for x is what's going to be on my outside of my synthetic division. Now the second part to our synthetic division, after we determine what values we are going to use on the inside and the 0 value we're using on the outside, is to think about how multiplication usually works. So the first thing that we're going to do is we're going to bring down the first digit, right? And then we're going to multiply and add. So I'm going to multiply this value on the outside times the first digit, and I'm going to put that result up here underneath the next column and then start adding. So 7 minus 3, which is the opposite of adding, but 7 plus a negative 3 is 4. And I'm going to repeat the process. Minus 1 times 4 is a negative 4. 13 minus 4 is 9. Negative 1 times 9 is negative 9. And 9 minus 9 is 0. And what happens is this last piece down here is going to be our remainder. So very similar to how we did long division, we always have to have some information about what is our result and what is our remainder. And if you think about our long division, what goes on the inside of our polynomial is starting with the third power. So this is the coefficient on x cubed, x squared, x, and our constant. And when you do polynomial division, because I'm dividing by a power of x, this result right here, this is my result. This result is 1 power less. So this 3 is going to end up being the coefficient on the x squared term. The 4 is the coefficient on the x, and this 9 is going to be my constant, with again the last digit here is going to be my remainder. So very similar to how we did our synthetic division, we need to write what all of this means. So what this means is when I take this polynomial and I divide by x plus 1, I'm asking first for what is my result after division. My result after division is this polynomial right here, again without that last digit, 3x squared plus 4x plus 9 is my result. With synthetic division, when we do this, because we're not using variables, the numbers we have are all the coefficients on the 1 degree less than what we started with. So again, this whole polynomial were all the coefficients of a third degree. And so because I'm dividing by a first degree, 1 times 2 gives us 3 in terms of our exponents. The other piece is I want to know what's happening with this factor. So this factor that I'm dividing by, this x plus 1, because my remainder is 0, just like it was with long division, that means that the x plus 1 is a factor. Again, being a factor, being a 0 are closely related that we're going to look at in our next set of our next module. So let's look at how this is going to play out again. Let's try another example, just kind of keeping in mind of the process. And again, we'll go through the process more than once so you can see how all of this works again. But again, it's a way of simplifying division. We don't want to always have to do long division. It's a shortcut which also gives us all of the same information. So let's try another. And I'm going to use the variable r this time. So let's look at r cubed plus 6r squared minus a 21r minus 18. And I want to know if I divide that by r minus 3, I want to know again two things. Is r minus 3 a factor or a 0? And what is the result after division? So again, I'm going to start with the same process. I'm going to look at my polynomial. I'm going to make sure that all the powers are listed. A cubic, second degree, first degree, no degree. And I'm going to start by writing my coefficients. Now remember, on r cubed, if I don't see any coefficients, it's automatically a 1 in front. So 1, 6, minus 21, and minus 18 are the numbers or the coefficients on the polynomial. Remember, when you make your box to leave a line, and leave that space so I can write my results when I'm doing my multiplication. And again, I need to put some number sitting here, and that's going to come from the divisor, the r minus 3. So again, I want to know if r minus 3 is a factor, and again, as we start moving on to some graphing, I want to know, does that mean where does r minus 3 create a 0? Again, this is going to kind of tell us eventually where polynomials will cross an axis, and so we're talking about zeros and factors in the same meaning. So now when I take r minus 3 and create a 0, I get that the value on the outside I'm going to be doing my work with will be a positive 3. And what you want to start recognizing is that it's the opposite of what I see here. So r minus 3 is a positive 3, just like the previous x plus 1, and I was using minus 1. So let's start the same process. first create your arrow down because I need to have the first digit to use as the beginning of all of my multiplications. Okay. 3 times 1 gives me 3. 6 plus 3 is 9. And I start the process all over again. And again, if you want to, you can put a little plus sign here to remind yourself that you're adding. 3 times 9 is 27. And when I add those two together, I end up with a positive 6. 3 times 6 is a positive 18. And again, when I add those down, I'm just going to write that that is my remainder. So again, no remainder is a good thing. It lets us know that, yes, this is indeed a factor. And again, in the next section, it will tell us if this is a 0. So I'm trying to get you to think about those two things together. So if this polynomial are the coefficients, if these are the coefficients of this polynomial, this was the coefficient on the r squared, r cubed, r squared, r, and constant, then again, my result is 1 degree less. So if this was r cubed, this is the coefficient on r squared, r, and then my constant. So my result after division is r squared plus a 9r plus 6. And again, if I want to know if this is a factor, again, because there was no remainder, that means that my divisor, my r minus 3, is a factor. Okay, so this was two examples that we had where both of our synthetic divisions came out to be factors because we had no remainder. But it was just an example to show you the process. In the next set of examples, we're going to talk about binomial factors which are not factors.